Hi, this is Mike Clancy, and today I am very excited to be interviewing Ray Feldman, a gentleman who played a key role in Project AZORIAN, the CIA's attempt to covertly recover a Soviet submarine from the floor of the Pacific Ocean in 1974. Ray Feldman was a Lockheed engineer who served on board the Glomar Explorer during the operation to recover the submarine. He was also mentioned prominently in the book Taking of the K-129 by Josh Dean, as well as the book Project Azorian, The CIA and the Raising of the K-129 by Norman Polmar and Michael White. He was responsible for designing, operating, and maintaining the communications link between the ship and the capture vehicle. If this link had failed, there would have been no chance to proceed with the recovery operation. Ray experienced every twist and turn of the operation firsthand, and he participated directly in the retrieval of materials from the recovered portion of the K-129. Ray, thanks so much for agreeing to do this interview.
My pleasure.
Ray, can you describe how you came to be involved with Project Azorian?
I was working on the Corona program at that time. It was first when it was first established. It was known as Discover, which was the cover for the Corona program. It's supposedly a biometric satellite, everything from bacteria to monkeys, which never really took place. It was always the first photo reconnaissance satellite. And in the process, I knew a lot of people who worked on various covert programs. And I also worked on the Hexagon and Gambit. And so I was well versed with all the people who had uh, SITK clearances.
So
And
Hexagon and Gambit were spy satellites?
excuse me.
Hexagon and Gambit were spy satellites?
Yes, they were more advanced than the Corona, and they had a much higher resolution. And there was also a mapping satellite called Argon, which I also worked on. It was a framing camera. I think there were only two or three launches of those. So I had a wide circle of people I knew who were involved in all these programs. And in 1971, I was working on something else, and I was approached by a former colleague from the Corona program, and he asked me if I would be interested in working on the ocean mining project. Well, it was in the news. Howard Hughes, manganese nodule. So, yeah, all very exciting. And I thought, well, yeah, I'd very much like to work on that program. By the way, here is in case anyone's interested, here is a manganese nodule, a
Hmm.
fairly good sized one.
Yeah,
Most of
that's a
them
big
are
one.
smaller. It's sort of a lumpy potato sized thing.
Hmm.
An interview was arranged with the manager of the Redwood City facility where the CV, the capture vehicle, was being constructed, and with Otchik, who is the manager, and also Jim Wetzel, who is the head of the Ocean Systems Division of Lockheed. And after talking with them for a while and explaining my experience, the things I had worked on, they knew that I had a lot of digital work in my background. And so they said they would be happy to have me on board. And I was equally happy to come on board and work on the program. And then they briefed me on what it actually was.
What
And
did you think when you heard what the real story was?
I was really surprised. It was a shocker, and I thought, oh well, another black program. Uh, so I agreed that yeah, I'd be interested in working on the program. And so I then went to the Sunnyvale facility of Ocean Systems, where most of the design work was being done, and worked with a small group of engineers finishing the design of the digital data system. The head of that small group of engineers had left suddenly, and I was there to replace him. I don't know what happened, why he left, but I sort of took over the final design of the digital data system.
Great. So you
And
worked,
that was my
yeah, yeah,
introduction to the program.
sure. So you worked initially up in Sunnyvale, but at some point you transitioned to the Lockheed facility at
Well,
Redwood
yeah,
City.
I did go to the Redwood City facility a couple of times to speak to some of the engineers who would be manning the consoles. But I didn't go into the barge because they were still doing a lot of heavy work in their big heavy equipment's being moved around, and they frowned on sightseers at that point. So I didn't see the completed capture vehicle until all the equipment's the electronic equipment was ready to be integrated with a capture vehicle and the control center.
So,
And when I first saw the whole capture vehicle in the barge, I was really amazed. It was immense, very impressive, and uh, and so that was my first introduction to the capture vehicle. After that, I had lots of times to work on the capture vehicle because all the electronics was contained in four pressure spheres on top of the capture vehicle. There was sort of a perforated steel planking on top where you could walk and access the pressure spheres. There were four of them. One was assigned for each console. There were four consoles in the control center, and the four were completely duplicated. They were redundant uh, pressure vessels. All the electronics was duplicated for redundancy, and uh, and so that work went on for some months. The capture vehicle was housed in the HMB, the used mining barge that was towed to Catalina Island, and the capture vehicle was transferred to the Hughes Glomar Explorer, and that's when all the work was being done, integrating the capture vehicle to the control center on the Hughes Glomar Explorer.
were you on the ship when they transported the capture vehicle into the ship?
Yes, yes,
Can you describe that scene for
it
us?
was a tricky procedure,
Uh-huh.
and it's like reaching into the cookie jar. The HMB had a roof that was would slide back, and the the Glomar Explorer had these docking legs which would come down and engage these huge pins. They were 48 inches in diameter on the ends of the capture vehicle. And once they were engaged, then the docking legs would pick up the capture vehicle into the moon pool of the Glomar Explorer. The capture vehicle was 179 feet long, consisted of two massive beams that were 30 feet deep, and they were connected by a series of trusses, and the uh, what we call the grabbers were connected to the sides of the pivoted to the sides of the strong back. The two massive beams were connected together, so they formed this huge strong back.
Wow.
Uh, the capture vehicle also had these four huge docking legs at each corner, which were designed to jack the submarine out of the soil, which it had been embedded in.
Fantastic.
Okay,
Now, Ray,
I have a
yeah,
I have a little diagram here. I'm not sure how well you can see it.
yeah,
Yeah. And
fantastic.
this shows the configuration for lifting the
Right,
uh, the capture vehicle with a target object, which we
right.
call the sub, the
hmm
target object from the bottom. Uh, the capture vehicle had eight uh, uh, what we call grabbers. Each grabber was a consisted of a beam and a davit.
hmm
You can see that?
Yeah.
Yeah. Each
Mhm.
one, there was a hydraulic cylinder for the davit and a hydraulic cylinder for the beam. And here
Mhm.
is the strongback,
Mhm.
highly schematized version
Yeah,
of the strongback.
yeah,
Yeah. So
fantastic.
the the program was progressing quite well. We finally got everything connected properly, and we're doing all the tests on the electronics. And the had the first integrated system test, which I didn't go on that one. Uh, but finally, everything was considered working properly. There were problems, of course, on the integrated system test. There was a problem with the well gates.
Mhm.
They were rattling around so badly,
Mhm.
and they had to be taken back and repaired. They were huge gates. They were 9 feet deep, and they could be pumped full of air to make buoyant, so that they would come up and seal against the bottom
Mhm.
of the Glomar Explorer. The moon pool on the Glomar Explorer was 199 feet long and 75 feet wide. The ship itself was 618 feet long and had a beam of 115 feet, too wide to go through the
Yeah.
Panama Canal.
Mhm.
So in transit from the Sun shipyards on the East Coast, it had to go around Cape Horn to
Mhm.
get to Long Beach.
Wow. Yeah, that's great.
Yeah.
So the integrated system test took place off the coast of Southern California?
Yes.
Mhm.
Yes. The integrated system test. Uh, Finally, on the see, it was July 19th is when we sailed out of Long Beach Harbor on the mission.
I think you're thinking of June 19th.
I'm sorry,
Yeah.
June 19th.
Yeah. So describe that. What time of the day did you leave?
Well, it had been a long day
Uh-huh.
preparing for for undocking, and we sailed out of Long Beach Harbor close to midnight on the
Mhm.
19th, and most everyone had gone below, and I stayed topside to watch the activities. Uh, there was no ceremony, just a few dock workers handling the lines
Mhm.
and a couple of people who looked like they were just observers. And I was thinking about the last time I sailed out into the Pacific under the Golden Gate Bridge on a troop ship bound for Korea.
Wow.
And I was thinking at the time that, well, I know there's some risks in this project, but I also thought that, well, I'm embarking on a unique adventure.
You're being very modest here for my viewers here. There was a lot of risk in this thing. There was
There
a lot of
was,
danger to the people, the crew on
and
the ship.
we talked about it amongst ourselves on board the ship. Once we were out I woke up the next morning, we were in international waters, and the Lockheed crew, there were 12 of us, and also some Honeywell people
Mhm,
who also shared the control center because they had their equipment in there too.
mhm.
And we were discussing some of the risks. One of them, of course, being what would the Russians do? We knew that we were contravening the sovereign immunity provisions of international law,
Yes,
international maritime law,
yes.
which stipulates that sunken military vessels
Mhm.
remain the property of the sovereign state that commissioned them.
Exactly right.
And uh, uh, salvaging such a vessel could be considered an act of piracy,
Absolutely.
could be an act of war or a
Mhm.
hostile act.
Absolutely.
And we weren't sure what the Soviets would do, the Russians would do. Would they attempt to board us? If they knew what we were doing,
Yes.
would they take some action against us? And so we were concerned about that. There were some contingency plans, which I can discuss eventually. But the other risk we were concerned about was that there was a strong possibility that there was an intact thermonuclear warhead
Mhm.
on the wreck.
Yes.
And we said, well, could that detonate? And we
Mhm.
were sure, no, no, that could be. But still, there was some concern.
The way I
Uh,
like to approach that is in my talks, I say, the probability of that nuclear warhead going off was very, very low, but not zero. So, yes,
Not zero.
not zero. That's right.
We also knew that the wreck was contaminated
Yes.
with weapons grade plutonium, which
Right.
would be plutonium 239. Now, plutonium 239 is an alpha emitter. Alpha rays can only penetrate can't even penetrate a piece of paper, and they can't penetrate the dead skin on your body. They can only go about a centimeter in free air. The only So you can hold a lump of plutonium 239 in your hand. It'll feel warm because of radioactive decay, but the risk is if you inhale even the
Yes.
tiniest particle,
Exactly.
it will lodge right next to living cells. Then that alpha radiation will assuredly cause a deadly cancer.
Yeah, that's a real
Uh,
concern.
so that was a concern.
Mhm.
And the ship was also a concern too.
Yes.
Uh, Not only because of all the heavy equipment that was being moved around,
Mhm.
but the ship had a sort of a flaw. The moon pool, I think I stated, was 179 feet long.
Mhm.
I mean, you have this big hole in the middle of the
Yeah.
ship.
Yeah.
It didn't have a centerline keel,
Mhm.
which could provide much of the structural integrity of
Right.
the ship.
Right.
All the weight that was being borne by the target object,
Mhm.
the sub, the capture vehicle, and the pipe string
Right.
would be bearing down on all that had to be transferred to the sidewalls of the
Right.
moon pool.
Right.
Now we're talking about 2,000 tons was estimated
Mhm.
for the for the TO, the
Mhm.
target object. 2,000. We knew that the CV weighed over 2,000 tons,
Mhm.
about 2,300 tons. At fully deployment, the pipe string would weigh 4,000 tons.
Mhm. It's a lot.
Plus the derrick and the gimbal
Mhm.
platform weighed another 1,000 tons. The gimbal platform weighed about 500 tons all by itself.
Mhm.
So there was this huge amount of weight. that had to be borne by the wing walls of the
Hmm.
moon pool. And we knew that if we lost well, before I go into that, we knew that the pipe string at full extension with a full
Hmm.
16,500 feet of pipe
Yeah.
in the string would stretch 40 feet.
Wow.
Can you imagine how much potential energy is stored in that 40 feet of
It's
stretch?
exactly.
So if for some reason
Hmm.
we lost a substantial amount of weight, such as maybe losing the capture vehicle and the TO, or losing a substantial amount of pipe,
Hmm.
that release of energy would shoot the remaining pipe through the derrick
Yeah.
and the shock would break the ship in two.
Yeah.
We
A
were
definite
pretty
possibility.
sure of that.
Hmm.
So that was another concern.
Absolutely.
Yeah.
Yeah. So
So anyway,
go
here
ahead.
we are sailing to the site.
What was the transit like to the site?
What's that?
What was the transit like to the site?
Well, we still had a lot of work to do.
I see. You're
We were
busy.
still troubleshooting things,
Yeah.
especially the electronics. I had to go down on the deck of the capture vehicle a couple of times and have one of the hemispheres removed from the pressure sphere to work on the electronics. And there was a lot of problems that we still had to resolve.
Hmm.
But we finally got to the site and we started to do our wet test. We lowered the CV on the docking legs. The docking legs grasped the CV at
Hmm.
each end on these 48-inch pegs that were sticking out of
Hmm.
the strong back. And that's how you lowered before you could transfer it to the pipe, you had to lower it down. The pipe, the bridle, there was a three-leg bridle that was laying flat on a capture vehicle. It had to be erected and attached to the pipe by an apex block and what was called a Dutchman. Only when you had the capture vehicle down on the docking legs could you swing the three legs up to connect to the apex block. So we were doing wet checks, and we were getting prepared to lower to undock. In other words, the docking legs would then swing
Hmm.
away, and the pipe would have the full load of the capture vehicle. At that point, the weather started to get real bad, and we had to bring the capture vehicle back into the moon pool and close the well gates. And then we got a call, a transmission from a British flag merchant vessel, Bell Hudson, that they had a seaman in distress. They thought he had a heart attack. And so that was a bit of a concern to us security people.
Hmm.
How do we respond? Well, you're supposed to respond always when there's someone in distress. You have to respond, and then also it would look suspicious if we didn't. Why are we not responding to this seaman who may be having a heart attack? So we responded back. We gave them our position. We said we were doing undersea work. We couldn't move. We couldn't maneuver and come to our site. They were about 40 miles, nautical miles from us. So they approached us, and we asked them to send a longboat over and pick up the doctor. We had a fully qualified ship surgeon. We had a sick bay that was fully equipped with all the diagnostic equipment that you might need. So they brought a motorized longboat over, and our ship's doctor and a medical technician went back to the Bell Hudson, and the doctor determined that he couldn't he couldn't figure out what was wrong, and he needed to bring the seaman back so he could do some tests, do some X-rays, do his EKG and all that.
Mhm.
And so they brought the seaman back, took him to the sick bay. Meanwhile, the boatswain of the longboat and another crew member were taken to the galley and given a meal. They wanted to keep him away from anything that he could see
Sure.
might be compromising. And anyway, the doctor determined that he had a couple of cracked ribs, not a heart attack. And the seaman finally admitted that he had been in a fight on board the ship. And so they taped him up, brought him back to the Bell Hudson, and that was the end of that situation. Although I did get to see a copy of the logbook of the Bell Hudson, the one page that documented that incident, and they didn't report that there was a fight. They reported that he had an inflammation of the cartilage between his couple of ribs.
They
I
wanted to
guess they
cover that
didn't
up.
want the maritime authorities to know
Yeah.
that there was a fight on board. So anyway, we went back to trying to uh, trying to undock and lower the pipe, lower the CV.
Mhm.
So radar picked up that there was a ship approaching, and after a while, it appeared on the horizon, and it was a large ship with a large radome. And as it got closer, we were able to identify it as a Russian missile tracking ship called a Khazma. And they stayed about half mile from us. And immediately, a large twin turbine helicopter took off. And that's when we realized, well, hey, he could land on our helicopter deck. And so a lot of crates were piled on the deck to prevent that possibility. And the helicopter circled us quite a lot, and you could see a side panel was open, and they looked like a movie camera to me. You could see two kind of spools at the back of it, and a large telephoto lens, and he was taking film from every possible angle, and even coming in very close, which was kind of hazardous because we had all sorts of superstructure, the derrick and cables and cranes and whatnot. And he ignored us. He just kept circling and taking as much as he wanted photographs. Finally, he went back, landed back on his Cosma, and did another turn on a little later in the afternoon. And finally, about a day later, the Cosmo left. And then a couple of days later, another ship appeared, and it was a trawler. It was a Soviet trawler, an SB-10. And they came in very close. They would circle us maybe 50 feet away. And they
Wow.
were again totally ignored our warning that we were stationary, we couldn't move, we couldn't maneuver, keep your distance. And they stayed with us for the entire time that we were we were in the recovery phase of the mission, and frequently came in very close. They always tried to collect any trash that was thrown overboard. We had in those days environmental concerns weren't all that important, I guess. So all trash was put into black plastic bags and tossed aside. On a couple of occasions, we had some uh, fanfold computer printouts that were just garbage. It was just core dumps that had nothing
Mhm.
on them but random numbers. And so we took some of these fanfold papers and put huge gobs of uh, called um, oh God, I can't recall the name of it, but it was the greasiest lubricant known to mankind. It was thick, it was worse than cosmoline, and highly uh, resistant to any sort of detergent or
Mm.
solvents. And we threw huge gobs of it in with a fanfold paper, and then pumped a little acetylene gas in it so it'd be buoyant, and then threw it overboard. And they would go after it. The wind would take it. It would be skipping over the waves. And we had images of maybe in some KGB scientific office somewhere that all this grease would be spread all over the place. Yeah.
You
So
guys are
that was
pranksters.
one of the fun things we did.
Yeah.
Anyway, we finally undocked and started lowering pipe. And originally, the specification was that would be able to move pipe at the rate of 16 feet a minute. And that was never the case. So they down specified it to 6 feet a minute. We never achieved 6 feet a minute. The heavy lift system was very prone to breakdowns.
Mm.
And so if we did 3 feet per minute, we were doing well.
Mhm.
And and while we were lowering pipe, there were all sorts of incidents happening. There was we had the the uh, the hydraulic pumps for the heavy lift system were there were 48 pumps,
Mm.
and they could put out 3,000 psi. They were all operating, I guess, in series. I don't know. I'm not familiar with pump technology. Um, but one of them exploded,
Mm.
apparently, and blew shrapnel around in the pump room.
Mm.
Luckily, no one was hurt.
Wow.
Uh, and then on another occasion, there was the way the pipe was handled was that there was a pipe storage well, and there was a sort of a, a derrick, not a derrick, oh, a device that would go down and pick up a pipe. They were arranged in order of size so that the lightest pipe would be on the very bottom and the heaviest pipe would be on the top. The smallest pipe diameter was 12 and a half inches, and the one on the very top of the pipe string was 15 and a half inches in diameter. And each pipe had a 6-inch bore for the hydraulic fluid to operate all the beams and davit hydraulic uh, cylinders, and also the breakout legs
Yes.
hydraulic cylinders. If you think of the pipe bore as a 16,500 foot high cylinder with a 6-inch diameter, the volume contained was about 25,000 gallons.
Wow.
Plus, all the fluid required for leakage and makeup dictated that we use seawater for hydraulic fluid.
Mhm.
Water, like most fluid, is essentially incompressible, so it works well enough. The water was filtered and a scavenger was added for lubricity.
Mhm.
And the the pipe was grasped by this device that would bring it over and drop it onto the pipe. There was a pipe boom that went up at an
Mhm.
angle to the derrick rig floor. and it had a cart on it, and the pipe would be set on the cart. The cart would go up the boom. At the top of the boom, the pipe handle would grab the box end, the female end, and swing it up to the top, and then it would drop down into the female end of the other end, the male end would drop down, and because it had the pipe thread had a really acute taper, that once it went in to the female, all it would take would be about 2 turns to have full engagement in all the threads, which were about 10 threads deep.
Mm-hmm.
And then there was what do you call this, subspinner, which would apply about 50,000 foot-pounds of torque on
Wow.
that to
That's a
tie.
lot of torque.
What's that?
That's a lot of torque.
It's a lot of torque. Yeah.
Yeah.
And in one case, they didn't torque it properly,
Oh.
and when it realized it was a really bad leak, had to withdraw the pipe and retighten it.
Oh.
Oh,
Okay.
that was a concern
Yeah.
also.
Yeah.
And also because it only took 2 turns to completely engage, it would also take 2 turns to disengage. That was a concern right there. So
Yeah.
while the pipe was going down and also being retracted, we didn't have hydraulic thrusters operating, because you couldn't have the hydraulics hooked up until the pipe was fully deployed, and then you
Mhm.
could attach the hydraulic sub at the top of the pipe
Yeah.
string. So in order to control yaw, because on this relatively long limber, this, it stretched so much, and the pipe could rotate fairly freely. So there were 2 electric thrusters on the capture vehicle, and they
Hmm.
were at the extreme ends of the capture vehicle. So although they were relatively small, they had a huge moment arm.
Hmm.
So one of the things I had to do was the people who'd be manning the console were practicing. They had all sorts of other work to do. So at night, although I was not manning a console during the recovery operation, I was mainly making sure that the digital data link was working. I had to do a lot of work on that. I sat for 12 hours manually torquing the electric thrusters to keep a positive torque on that pipe string. I look at the heading of the ship and look at the heading of the CV, and if it started to wander, I torque the pipe. There was a little control. I could torque
Wow, that's interesting.
the
It's the first time I've heard
thrusters.
about that.
Yeah,
Yeah.
so I did that while the actual crew who would be manning the
Hmm.
consoles were practicing and doing all the procedures and all that. So
Yeah.
I did that at a 12-hour shift at night, beside my regular daytime work
Yeah.
of keeping
You were
the digital data link working.
you were busy.
I was busy, yes, yes. So oh yeah, also another time we had that boom had a huge counterweight on it.
Hmm.
And at one point, the cable holding the counterweight, the steel wire rope, parted and dropped the 30,000-pound counterweight onto the deck, which
Wow.
provided a bit of a shock to everybody.
I guess so. It's lucky you didn't go through the
Everyone.
deck.
Finally, we get down to the bottom, okay, and we couldn't see the sub yet with the uh, we had uh, we had 12 cameras
Mm.
on the capture vehicle, and about 26 lights to illuminate the bottom. And it wasn't until we got to about 200 feet above the bottom that we could actually see the sub, and it was really clear. It was amazingly clear. We could see all sorts of detail on the sub. We could see crabs crawling around. We could see grenadier fish, rat-tail fish. And before we could even see the sub with the optics, we were able to get a image of it on the CTFM sonar, the continuous transmission FM sonar. So we knew we were pretty much over the over the sub. We had two cameras that had pan and tilt capabilities, so that we could align the capture vehicle with 2 points that had been selected as major alignment points. One was a towing eye at the bow of the sub, and the other was a crack on the aft end of the hull. And so after we had full alignment and we knew we were directly, precisely over the sub, we could then start bearing. The beams and davits were extended outward so that when we came down, we could bury the davits into the soil. So we went down. The breakout legs came in contact first the aft. It was on a slope, about 10 degrees. So the aft breakout legs hit first, okay? And then as the pipe was lowered, and then the forward breakout legs then came in contact with the soil. The breakout legs had these cookie cutters, they were called. They were folded down as when the capture vehicle was on the docking legs and below the ship. They were folded down then by the divers, and so they penetrated into the soil to keep the capture vehicle from sliding. And then once they were fully penetrated, then the pressure was let out of the breakout legs, so the capture vehicle, by its own weight, started to bury the davits into the soil. And then more pipe was lowered, and as you lower more pipe, the weight that was being put on those davits would increase to make sure that they penetrated deeply enough that when the davits were closed, when the beams were closed and the davits brought up, that they wouldn't strike the hull. The concern was if you struck the hull, then the hull might shift. The capture vehicle was designed to pick up the sub in a specific attitude on the sea floor. The davits were arranged so that the sail on the starboard side, the sub had been on a sort of an 45-degree angle. So the sail was sticking out, and there was a gap on the grabbers. There were only 3 grabbers on the starboard side to leave room for the sail. And there were 5 davits, 5 grabbers on the port side. So it had to be precisely aligned. And so if the hull got struck and it got shifted, somehow might not be able to align and pick it up at all. So the davits were not sinking in as deeply as possible as they thought it should be. And part of the problem was during the Glomar 2, which did a survey on the site some months before, sometime earlier, they had a device called a Sumax dork, Okay, you can
Mhm.
get the image. And it was meant to penetrate the soil, get a soil sample so that you could know how hard the soil was. And so for some reason, I don't know what the details, but the dork was lost. Never did get any soil sample.
Mhm.
So we had no real idea how hard the soil was at that point. Well, the, the davits were not penetrating as deeply as we thought they should be. And the mission director, the individual who was directing the operation, was not a Lockheed employee, and that was one of our gripes. He was directing the four Lockheed employees who were manning the consoles, and he decided to offload more weight. And that was a concern because we had knowledge of what the grabbers were constructed of, and we were concerned about having too much weight being placed on those davits. The davits, by the way, had water jets on
Mhm.
the points, on the extremities, to help excavate the soil. And it was thought by some of the Lockheed people who were manning the console that if we just go slower and let those water jets do the work, we could penetrate deeper and deeper, and we wouldn't have to offload the weight, more weight. But the guy who was in charge of that portion of the mission said, no, let's unload more weight. And at some point when this process was going on, uh, there was a sudden shock that was transmitted up the pipe, and the TO seemed to roll. It seemed to
Mhm.
roll downwards. The sail went further down, and oh, that's probably when beam four broke, actually fractured. And but we didn't know it at the time. We couldn't tell. There was
Mhm.
no camera looking in that direction, and the pan and tilts were not in that place where they could look at that particular beam. Uh, but anyway, we had no choice but to continue. Uh, finally the davits were penetrated as far as we could go, and the beams were closed, and we had the TO fully enclosed in the davits that remained. Um, and so at that point, we started to try to achieve breakout. So breakout was achieved. You couldn't depend on just a pipe to pull
Yeah.
that out of the suction of the soil, and that's what the breakout legs were. They could jack the capture vehicle with a TO out of the soil. As I said, they were about 12 feet in diameter, very large, very large hydraulic pistons, but they only needed 50 psi to work. If you
Mhm.
work it out, 50 psi at about 12 feet in diameter, that's 400,000 pounds of force that could be exerted.
Mhm.
So that was plenty good. So all four of them working alternately broke. We could see it was okay. We broke free. It was above the soil, and then we started pulling pipe.
Mhm.
And at that point, things seemed good. We had the TO, we had the whole TO there, 135 feet or so, whatever it was. The aft end was very jagged and broken. So
Yeah.
whether you wanted to call it 140 feet or 130 feet, depend on where you actually measured
Yeah.
the target object. And so we started on the way up.
But then there was a problem with the heavy lift system. You had to put it back down, right?
Oh, yes, right. Important
Mhm.
point. Thank you so much.
Yeah.
Yes, the there was a heave compensator
Mhm.
on the lift system. The heave compensator were two massive hydraulic system to provide a soft spring.
Mhm.
The pipe itself was a huge spring.
Right.
So the heave compensator, it had uh, it had a stroke of about 8 feet.
Mhm.
And so it could provide, and it was an air oil compensator, so it could provide an air cushion and damp out some of the motion, which could provide a resonance,
Yes.
and that broke down, and so they had to stop and repair that. And in order to repair that, they had to let the capture vehicle back down onto the soil. Now here we are with the capture vehicle with letting
Mhm.
down on the soil with the
Yeah.
weight of the TO. It was never intended for that.
Mhm.
All that compressive load was was not accounted for in
Yeah.
the process of designing the grabbers. And that's where probably beam five cracked, although it hadn't propagated all the way through. But beam five cracked at that point,
Mhm.
and we weren't aware of it. But then after they repaired the heave compensator, we started back up again.
Mhm.
Okay. I'd like to point out another fact of the heavy lift system. It had this, I mentioned the gimbal platform before. Okay. It was a system that contained four huge roller bearings. I mean, biggest ever built. They
Mhm.
were more than 6 feet in diameter. Each one weighed 5 tons or more.
Wow.
So the roll bearings were essential to prevent a bending moment on the pipe if the ship rolled more than 8.5 degrees. And the pitch bearings were also essential because they had a capacity of 5 ± 5.5 degrees. And so, okay, back to the lift system. Here we are coming up,
Mhm.
and we were doing pretty well. Pipes were being withdrawn from the string at a fairly good rate. The more pipes that were being withdrawn, the faster things were going because there was less weight on the system. And we were about halfway up when there was a sudden shock that was felt everywhere on the ship. And in the control center, we didn't feel much of that because the control center consisted of two vans that were mated together, and they were on isolation pads. So we didn't get much of the shock through those pads, and we could see on our video that everything looked okay to us, but we were notified by the people on the heavy lift system that the snubbers, that was the heave compensators, were driven to their limits, and that it was obvious that some weight had been lost, because if they're driven to their limits, that
Mhm.
meant some weight must have been lost. But they didn't know how much weight. And so they said, "Hey, how does it look on your video?" We said, "Hey, it looks great. We can see everything still there. We can see the
Mhm.
TO." Well, it turned out that someone had uh, turned off the recording of the video. And when you did that, it just displayed the last frame. It
Mhm.
was a frame that consisted of 60 individual 60 frames per second. Each camera had 5 frames per second. And when you turned off recording, it just kept refreshing the last frame that had been
Mhm.
received. And we couldn't see that because the recorders were in another room. And the guy who turned off the recorders was concerned because we had so much just so much tape on board, and everything had taken so long to get down and to get back up. He thought, well, we're running out of tape. And this
Wow.
is all very quiet now. Nothing much is happening. So we then turned on recording, and we could see immediately that,
Hmm.
yes, we've lost most of it.
Wow.
Yeah. Well, we knew we had a piece. There was a piece of the bow hanging on the uh, davits 2 and 3. It looked like about a 40-foot piece or so. So there was nothing we could
Yeah.
do but just bring the rest of it up into the moon pool, which
Yeah.
we did. And it was brought up into the moon pool. The well gates were closed, and the water was pumped out. I guess I think it was on the 4th of July. Yeah. And
Well, the 4th of July is when you started the descent. So this was later in July,
that,
I think. I think this was maybe it was the 4th of August because 4th of
yeah,
July
fourth of,
is,
I'm sorry, 4th of August. I'm
yeah,
getting
there you
late.
go.
At this point in my life, I get dates mixed up easily.
No
Yes, it was on
problem.
the 4th of August,
Yeah.
and uh, we could see that the piece that we had was still there, and uh, the the hazmat people went down into the well after it was pumped dry, and they did a survey, and they determined that yes, there was a radioactive contamination with the plutonium debris. And they also determined that there was nothing free floating, which was the most hazardous, and that because plutonium is so heavy, so dense that any particles would float down and adhere to whatever it touched.
Hmm.
And so there was no concern about breathing plutonium particles, but that if you did any cutting with cutting torches, then you would have to wear a breathing apparatus because
Hmm.
vaporized plutonium would be really hazardous.
Yeah.
Uh, so after that was determined, exploitation of the remains of the sub was undertaken. Uh, and
And you were
uh,
involved in that, right? You actually went inside the target object?
yes, I help with the exploitation, and it was very messy. Uh, uh, on the part of the as far as I didn't go all the way in to the very tip of the pressure hull, what was left of it, but I did do some work on the outer portions, and it was a, a layer of material that was a foot or two deep that was compressed clothing and pieces of broken equipment, and you had to. It was all very hard to get some of the stuff out. You really had to pull it,
Hmm.
and um, it was like an archaeological site,
Yeah.
I would imagine. Yeah,
Wow.
and I could not see anything of much intelligence value, but we did have 2 nuclear-tipped torpedoes that were recovered from the very forward portion of the pressure hull, and they looked like they had been crushed, but apparently the warhead was intact,
Hmm.
and so that in itself was quite an intelligence coup.
Sure.
Uh, Samples of the hull were taken, of course, to see what sort of hull material was used, the construction techniques, welding techniques, and so on.
And
Yeah.
so some bodies were recovered, and I understand there was a morgue on board the ship, so the bodies
What's
were
that?
some
Yeah,
bodies were recovered.
6 bodies were recovered, uh, pretty intact apparently, and uh, they were pretty much entombed by all sorts of debris, mattresses and such. Otherwise, the crabs would have gotten them, and so they would have been stripped to skeleton.
Hmm.
But they were pretty much intact because, as I say, they were entombed in with all sorts of debris that
Hmm.
the crabs and fish couldn't get to.
Yeah.
Um, uh,
And they were placed in a morgue on board the ship.
what's that?
Their bodies were preserved inside a morgue.
Yeah, there was a sort of a mini morgue,
Yeah.
refrigerated. They
Yeah.
were immediately taken to the. I mean, because at the bottom, it was the temperatures are just about freezing
Yeah.
at that depth, and also the pressure apparently inhibited any sort of bacterial decomposition. And so they were, as I say, they were pretty intact, suffering from traumatic wounds,
Hmm.
and but otherwise intact.
So this
And
went
so
on.
they were
Yeah.
immediately refrigerated because
Right.
once they brought to the surface, the decomposition started immediately.
Yeah.
So they had to be, put in the refrigeration. Yeah. I felt sad about the submariners. They were young men engaged in hazardous duties to protect their nation from what they felt was a threat. And we respected them for that. And we treated them respectfully. Yeah.
So the exploitation continued as you sailed back to Lahaina?
Yeah, as we sailed back to Lahaina, we continued exploitation as much as we could. There was a crew change in Lahaina that would continue the remainder of the exploitation and disposal of the wreck, and also burial at sea of the
Mhm.
six Russian seamen who had
Yeah.
been recovered from the wreck. Yeah. Uh, and as far as I was concerned, at Lahaina, I left the ship and took a little vacation on Lahaina before I went back home. Yeah.
Well, fantastic, Ray. That was just absolutely fascinating. And
Also, while we're at it,
yes.
I've neglected to show the this is the electromechanical
Oh, yes.
cable
Yes. Can
that,
you describe that a little bit?
yeah, okay. In the center, you can see the coax
Yeah.
cable, and that was for the video.
Yeah.
The video was the 60 frames per
Hmm.
second,
Hmm.
5 frames per second for each camera.
Yeah.
And then there were these, that was twisted shielded pair. There
Yeah.
were all those, there were six-inch of shielded pair that were used for both the commands going down to the capture vehicle
Hmm.
and telemetry being returned.
Yeah.
And also there were two of these for acoustic signals.
Uh-huh.
And then there was these heavy triple aught gauge copper wires for
Mhm.
power. Power was sent 2,000-volt power with capacity of up to 200 amperes, were sent down to operate all the electrical equipment on the capture vehicle. There were transformers on the capture vehicle that were converted, transformer to 440 and 220 and 110 volts for the various different equipments.
And it was
And
three-phase power, I see.
what's that?
Three-phase power.
Three-phase delta
Hmm.
configuration.
Yeah.
Yes. And it was double armored. You can see the armor around here.
Yeah.
And I cut these to make a display. It was a bitch to cut.
I can imagine.
Yeah. All right. So that's one show and tell. And also, everyone on board on the mission received one of these. I don't know if you can read,
Yeah.
use capture vehicle, and it had nodule embedded, and this wasn't to support the cover story that this is, so we
Yes.
could show these around. So
Yes.
we were recovering.
Where did the nodule come from? Was it actually recovered part of the mission or
No,
elsewhere?
no, no, these were
Yeah,
not, because the ones on the mission were contaminated
I
by
see.
plutonium.
Plutonium.
In fact,
Wow.
ironically, we did recover some
Yeah.
nodules on the
Capture vehicle.
TO. They were lodged between the pressure hull and the outer hull.
Wow.
Apparently, as the TO was sliding a
Lying
bit
down.
down, they were scooped up. But we didn't take any of those. Those were not considered worth keeping
Yeah.
as souvenirs because they're very porous. They're very porous, and they had all sorts of contaminants in them. Yeah,
Yeah, I
but
can
no, this
imagine.
one is not from the.
Yeah.
This was actually Lockheed had been involved in ocean mining before this. They
Hmm.
so and also continued after this
Yes,
program,
I'm aware of that. Right.
which never came to fruition.
Right.
Yeah,
Right.
but they had been interested in ocean mining before that and had
Yeah.
done some surveys also on their own. So
Fantastic.
these manganese nodules, which are now called polymetallic nodules,
Right.
no longer manganese nodules. Yeah.
Right. That's right.
And of course,
Now it's
today, now
becoming,
that's big news.
I know it is indeed.
Yeah.
Well,
And
anything else, Ray?
here's one last show and tell
Yes.
on the, when I was on the Corona project, I was on the mission of
Wow.
when we did our first recovery.
Were you on the plane?
What's that?
Were you on the
No, no, no.
airplane?
I was on the plane, not on the plane, but I was on
Yeah.
part of the
Right.
program, and of course, this was given to people who were involved.
Yeah.
I could never forget the date, August 11th, because that's my birthday.
Oh, that's
So,
perfect.
yeah,
Well, you've had an amazing career, Ray. And so I want to thank you very much for this fascinating account of your experiences on board the Glomar Explorer.
thank you so
This is
much.
one for the history books, this interview.
What's that?
So this is one for the history books.
Yes, I think so.
Yes. So Ray Feldman was a very key player in what has been described as the CIA's greatest covert operation, Project AZORIAN. Without his contributions, the project would have had no chance of going forward. It's my sincere hope that this video will serve as an important oral history to help future generations understand what the world was like during the Cold War and to what lengths the two principal adversaries in that war were willing to go in order to gain an advantage. So thanks again, Ray. It's been a privilege to get to know you and to interview you. And
Thank
to my
you.
viewers, this is Mike Clancy. Thank you for watching. I hope you enjoyed this video.